The integral from pi over 6 to pi over 4 of tangent squared x times secant squared x dx. Walking up to this problem, I say, hey, it's a trig problem. I sure hope the derivative of one part equals the other part. So here's where it's really helpful to have all of our trig derivatives memorized. Since the derivative of tangent of x is secant squared x, that's what I'm thinking about for the u substitution. I'm going to let u be equal to tangent of x, which means my differential looks like du is equal to secant squared x dx. I have exactly what I need in the problem. It matches perfectly, so I don't have to do anything to adjust the numbers. If I started to rewrite that, that tangent squared x is going to become u squared, and then secant squared x dx becomes du, and I'm going to integrate this. Thinking about the antiderivative of u squared, again, I've got a variable raised to a number exponent. I add 1 to the exponent, divide by the new exponent. Now I'm going to check, is it a definite integral or an indefinite integral? This is a definite integral because I have bounds. So that means that I have to come back in here, and rather than doing this with a plus c and then translating back to x's, instead, I need to translate the bounds. When x is pi over 6, u would be equal to tangent of pi over 6. So now I have to remember, what is tangent of pi over 6 again? If you are a unit circle person, great. If you're not a unit circle person, there are lots of other ways to memorize our special angles for trig functions. I happen to use special triangles. So for me, I know that this one goes with an equilateral triangle. So that side is 2, and then that's an angle of pi over 3. When I cut it in half, that bottom side will be 1, which makes the height square root of 3. And because I bisected that angle, or I cut the angle in half, that is pi over 6. When I'm looking for tangent of pi over 6, I'm looking for opposite over adjacent. So for pi over 6, the opposite side is 1, and the adjacent side is square root of 3. To adjust our other bound, when x is pi over 4, that would make u tangent of pi over 4. And this one doesn't go with an equilateral triangle. This one instead goes with a square. And if all of the sides on my square are 1, and when I cut it in half, the hypotenuse will be the square root of 2, because all the interior angles were pi over 2, or 90 degrees. When I cut it in half, it's 45 degrees, or pi over 4. So tangent of pi over 4, looking at opposite over adjacent, that's going to equal 1. When I translate back to our u substitution, again, I have to keep the pieces in the place that they were in the original integral. Since pi over 6 was at the bottom, my 1 over square root of 3 goes on the bottom. And since pi over 4 was at the top, my tangent of pi over 4 being equal to 1, that's what goes at the top. So my final step in terms of evaluating the definite integral, so we found the antiderivative. And now we're going to plug in the bounds. So I'll plug in the 1. And plug in the 1 over cube root of 3. I get a lot of questions about whether you need to simplify that or not. My advice, don't, unless you have extra time on the test. It's not worth making a mistake on there. Better to leave it alone, know that you have the right answer, and if you lose a point because you didn't simplify, it's probably better than simplifying incorrectly. If you have a lot of time on the quiz or the midterm, then absolutely it's great to do the practice of simplifying. And I would practice it when you're working on homework problems.